So in this video, I'm going to take you through a couple of different algorithms, show you how you can break them down, and also show you how you can run trace tables on them. It's a skill that you absolutely need for your exams. So we're going to have a look at this right now. So here's our first algorithm. It's a very simple one. So we're going to start breaking this down a little bit. So it's got a bit of input, so n becomes user input. The back arrow means assigned to and storing. X is an integer type variable. A for loop is being used to run through the data. It's called a definite loop. So a for loop goes around a certain number of times. So it's a definite loop, it has a definite ending. N must be an integer because it's the endpoint of the for loop, so we can tell that by looking at the way that the algorithm is constructed on line 3. Y is our loop counter, probably should have given that a better name, but Y will do for now. And what will happen is if we set n to 4, then Y will go 1, 2, 3, 4. Now quite often what you'll see is you'll get a column in the trace table for the loop, and if it's a simple for loop like this one, it's very easy to pick up a mark or two for working out where this loop starts and where it ends, and it's a sort of very quick way to get yourself some marks and get lift off. So let's make a start with our actual trace table. Now the way that trace tables are constructed is that they have variables, identifiers, in different columns, and you have to fill in those columns as you go, and you fill them in line by line. If you've got a loop, you could fill in an entire column in one go, but generally the advice is that you fill them in line by line. Each line usually represents the next stage of the algorithm, so for example the next iteration or the next looping of a for loop or a while loop. They nearly always give you a starting point. So here they've given you a starting point and said that n is set to 3 and that x is set to 1. And what they want you to do from now is to start filling in these columns and rows. And I'm going to show you how this works and how it builds up. So this is step 2 of our trace table. In step 1, we simply set the n to 3 and the x to 1, but now they want you to start working on the table itself. Now what I always advise people is to go to the next line. Don't try and start on the first line that they've given you, move to the next one. You won't have to use necessarily all of the lines they give you. You might find that you stop a line or two before the end. They don't necessarily give you the same number of lines as the answer requires. So let's have a look at what's happening. So the first thing that happens is that y gets set to 1. The next thing that happens is, and the reason that happens is because for y equals 1 to n, so 1 to 4, so we're going to start at 1. The next line that happens is x becomes x plus y, so it becomes 1 plus 1. So in other words, x becomes 2. And now what we're going to do is we're going to loop back to the beginning of the for. Okay, well let's do that again. So let's loop around that again. This time y becomes 2, so from y equals 1 to 4, so we've done 1, so now we're on 2. X becomes x plus y, so x is 2. We're going to add on y, which is also 2, and that gives us 4. Okay, let's have a look at our next step. So y now is going to be changed to 3. So 1, 2, 3. X becomes x plus y. Well, x was 4, y is 3, so x becomes 7. And here's our final step. So y now becomes 4. Well, that's actually the end of the loop. So for y equals 1 to 4. So this is the last time through. It's now going to do x becomes x plus y. Well, x is 7, y is 4, so x becomes 11. Now, what happens now is that the algorithm finishes at this point. It's got to the end of its for loop. And that's one thing you need to watch out for. That's a difference between algorithms that you might see in pseudocode and algorithms that you would program in Python. Python for loops end at n-1. For loops in pseudocode just go from 1 to n, so 1, 2, 3, 4. Okay, and you just need to be a little careful of that. Okay, let's have a look at a slightly more difficult algorithm. So in this case, we're using an array, a one-dimensional array, and it's called group sizes. They'll always tell you where the arrays start. Usually they start at 0, so 0, 1, 2, 3, but that's not always the case, but they will tell you. We've got a while loop, which is an indefinite loop. It goes around until it meets its condition, in which case it will finish. In this case, the condition is while the value of index is less than or equal to the size of array group sizes. So in other words, while the index is less than or equal to however big that array is. Each element in the array is accessed by using its index position. The index is shown in square brackets. This particular array has indexing starting at 1, just to keep things really simple. So the first position in the array is 1, so the value of 20. The second position has a index of 2, and so on. So what that means is that the group sizes value of 32 is in position 4. 1, 2, 3, 4. It's right at the end. Have a look at this array and its construction. Have a look at the algorithm. It's very similar to the stuff that we went through when you went through the arrays work, so there's nothing particularly different here. And it's a very, very standard way of presenting this kind of algorithm, this kind of program. Okay, so what we're going to do is we're going to show you how to work your way through the trace table for this algorithm using a one-dimensional array. The orange circle is going to move and help you navigate our way around the algorithm, so it'll tell you where we are, and as we go along I'll fill in the trace table, and the arrow, the blue and the white arrow at the bottom, will tell us a little bit about what that particular part of the algorithm is doing. So we're going to start off with setting things up. So we're going to set this array up, group sizes. So because it's an array, it goes in square brackets with the values just after it. Moves to line 2, and it sets the number of places to 0. I'm going to record that in my trace table because that's what one of the identifiers that it wants me to trace through. Next thing we're going to do is we're going to set total to 0. We then move to line 4, set the index to 1. We're going to record that in our table because that's part of what we're being asked to do. So this whole really section is about setting values, setting things up, initializing the data. Okay, so now we're on the while loop, the bit that sometimes people get a bit scared of. Notice that what I've done is I've faded out the colours of the numbers in the table just to make life a little bit easier, a bit clearer. So if we have a look at this while loop, it goes while index is less than or equal to length len group sizes. So while the index identifier is less than the size basically of group sizes, well, the length of group sizes is 1, 2, 3, 4. So at the moment 1 is definitely our index, so 1 is less than def 4. So we're going to go into line 6 now because that condition is true. We've now got an if statement, so if no places is less than group sizes index. Group sizes index is group sizes 1, well that's 20. Now because no places is 0, 0 is definitely less than 20, it's going to run line 7. And what line 7 does is say, well, what we're going to do is we're going to replace whatever's in no places with whatever's in group sizes index. So in other words, what this is trying to do is to find the highest value in group sizes. It's basically going through and looking for the biggest group size that we can. Get to the end if, and then we get to the index. This adds 1 to the index, so index goes from 1 to 2. Move to the end while. And now we move back up to the top of the loop. So let's start with step 3. We're at line 5 now. Faded out the rest of the trace table, but we still need to use that last line we created in step 2. So while index is less than len group sizes, well, len group sizes is still 4, that never changes, but index is 2. 2 is definitely less than or equal to 4. So we go into our loop. If no places is less than group sizes index, well, group sizes index here is 30 because its group size is position 2, index 2. So the number of places is no places is 20, our group sizes index is 30, 20 is definitely less than 30, so we go into line 7, replace our 20 with our 30, add 1 to the index, hopefully you can see a pattern emerging here, get to the end while, loop back up to the beginning of the while loop. Okay, step 4. Now, index is 3. 3 is still less than or equal to 4, so it's still less than 4. Group sizes index is 27, so index being 3, so group sizes index is the value 27. However, this time round, no places is 30. Well, 30 isn't smaller than 27. So we're actually going to skip line 7 and go straight to line 8. No places stays as it is. Index changes, goes up by 1. Get to the end while. Back up to the top of the while. Last step, again, we're starting at the beginning of this while loop. So while index is less than or equal to len group sizes, so 4 is now what our index is, so 4 is equal to 4, so that's okay. We go in, our group sizes index, so group size position 4 is 32, so what we're going to do is we're going to end up doing our swap. There it goes. Our index now changes from 4 to 5. Now we're back to the beginning of the while loop, but while index is less than len group sizes is still 4, but our index is 5. Well, 5 is certainly not less than or equal to 4, so the while loop therefore doesn't run, it finishes. And what it's going to do is it's going to skip to line 11, does a bit of output, that's not recorded in our trace table, that doesn't matter, and then the algorithm finishes. And that's the process from beginning to end. Gives you an idea of how you can trace through one-dimensional arrays using a while loop and using an if statement. And that's a very, very common style of question. Sometimes it'll be a while loop, sometimes it'll be a for loop. There's nearly always some kind of selection statement, an if statement in the middle of it. And you need to be able to keep a track on where things are going and how you can trace things through.